this is Dr. Mears. Today we are going to be learning about arithmetic sequences. So this is in your ISN, so don't glue it in yet, but let's first work inside. So open up that first door. We're going to be listing the explicit rule for arithmetic sequences. So we've actually talked about arithmetic sequences a little bit, but I want you to get it down in your notes so you have the arithmetic rule and you know what each of these stands for. So the arithmetic rule is a sub n equals d times the quantity n minus 1 plus a sub 1. So n is going to be the term number. A sub n is going to be the nth number. No, sorry, the nth term. Good thing I'm writing it. A sub 1 is the first term, and D is going to be the common difference. So take a moment, you may pause, and you may fill this in your little note sheet. Okay, welcome back. So what we're going to do is we're going to be doing this example. This example, let's first determine if it's an arithmetic sequence. So what we have to determine is the common difference. 4 to 7, that gives us a common difference of plus 3 because we have to add 4 and 3 to get 7. So let's see what we have to add to 7 to get 10. That's plus another 3. Let's find that next term. The next term we would add 3, so that next term would be 13 and so on. So we said that this is an arithmetic sequence because we have a common difference and the common difference is plus 3. So let's find the arithmetic rule. So we're going to write a sub n equals the common difference, which is 3, times the quantity n minus 1 plus a sub 1. Now a sub 1 is that first term, so it's that first term here plus 4. Here I said use Pemdas to simplify. So what I would like you to do is I would actually like you to get rid of these parentheses. How you do that is you use the distributive property. 3 times n is 3n. 3 times negative 1 is negative 3 plus 4. Then we see a sub n equals, we can combine these two terms because they're alike, so I'm going to write down 3n, negative 3 plus 4 is positive 1. So this is our arithmetic rule simplified. It looks very similar to what we've been working on. Okay, next let's go to a situation. We have chairs for an orchestra are positioned in a curve with a conductor at the center. The front row has 16 chairs, with each successive row has 4 more chairs. So what happens, I'm just going to draw a little picture. So in orchestra, there's the conductor is here. This would be the conductor. And so there would be a little circle of chairs here, and then more chairs here, and then more chairs. So each time the semicircle gets bigger here, more chairs are being added on. So that's what it looks like. So let's go. Row 1, we're going to be starting with 4 chairs. Oh, actually, I'm sorry. Not 4. That's what we're going to add on. We start with 16. So row 1 has 16 chairs. Row 2 is going to have 20. Row 3, 24. Row 4, 28. Row 5, 32. Row 6, 36. And so what happens here, you can see we have a difference of plus 4, plus 4, plus 4. So there's our common difference. A recursive rule. Now remember, recursive rule is how to get from one term to the next term. Let's write that in. How to get from one term to the next term. So how do we get from 16 to 20? And when I talk about terms, I'm talking about the chairs because that's what the problem is about. The problem is about the chairs. So how do I get from 16 chairs to 20 chairs? So I get from one term to the next term by adding 4. To get to the next term, add 4 to the previous. And I'm using a lot of vocabulary here, so make sure you pause that and write that down. Now our explicit rule. Our explicit rule, remember, we're going to be using a sub n equals d times the quantity n minus 1 plus a sub 1. So here we have a sub n equals, d, remember, is our common difference. Our common difference is 4 times the quantity n minus 1 plus a sub 1, which is 16. So the a sub 1 is that first term right there. Let's simplify it. A sub n equals distributive property 4 times n minus 4 times n minus 4 times 1, which is 4, or you could say 4 times negative 1. Don't forget about your 16. These are like terms. So then let's say a sub n equals 4n plus 12, because negative 4 plus 16 is 12. So here is our explicit rule simplified, and here was our recursive rule. Okay, let's graph it. When we graph it, our row is going to be our x variable, and our chairs are going to be our y. So as you can see down here, we have row is our x and chairs is our y. It's nicely labeled for us. Now our rows, let's see what we count by. 1, 2, 3, 4. Well, that's pretty simple. So let's just count by ones. 1, 2, 3, 4, 5, 6, 7. You go as far as you want. I'm going to go to about 7. And then the number of chairs. Since I'm increasing by 4 here, I believe I want to count by 4. So I think that would probably look really nice. So let's start at 4, 8, 12, 16, 20, 24, 28. Let's do that. Okay. So, 32, 36. We can even go to 40. Let's go all the way up to 40. All right, now let's plot these points. The first point is 1, 16. So I'm going to go over to 1 and then up to 16. So here's our first point. The next one is going to be 2, 20, then 3, 24, then 4, 28, 5, 32, 6, 36, and you can keep going. And what I want you to notice here is that the points fall in a linear pattern. So let's write that. Points fall in a linear pattern. And I'm hoping you're going to start to realize that this a sub n equals 4n plus 12 really reminds us of a linear relationship in a function. And these points fall in a linear fashion because that's what arithmetic sequences are all about. It's determining the explicit rule, and we're actually going to be turning it into a linear function and graphing it. So that's coming up next. But let's concentrate on the explicit rule, the recursive rule, graphing it, and that's about it. So this has been Arithmetic Sequences. Thank you.